Hello. Um, we are going to continue Chapter 7. By the way, I got a new headset. I hope it works as good as the previous one. The previous one was broken. So let me start Chapter 7. The main idea of this chapter is to understand the random sampling. So in the previous chapters, we considered a random experiment as to generate one observation. But now we are going to treat random sampling as one experiment. So if you conduct one experiment, then you are going to get n observations, and you may calculate something out of them, for example, the average. So then we will try to understand how the average is distributed. In particular, we wonder what's the relationship between the distribution of the average generated by a random sampling and to the distribution of a single outcome that was generated by the original experiment. So, and we call the distribution of the average as the sampling distribution. And we learned some important results. And as you see from these graphs, what's interesting here is as the sample size increases, always the distribution looks like a bell curve or normal distribution. So that is correct. That is a general result. And it's a great result. It's a very interesting result. And we learned three properties. One is that the mean of the average, the expected value of the average, equals to the expected value of a single outcome. And second, but the variance of the average is the variance of one single outcome divided by n. So that means as n increases, the variance decreases. Standard deviation is just the square root of the variance. And finally, the distribution of x bar converges to a normal distribution as the sample size increases. So, in particular, this is the most surprising result because no matter what distribution you had, in the end, if you repeat a certain number of sample size experiments, the distribution of the sample mean is going to be a normal distribution. So it's a very strange but important and powerful result. And two most famous fundamental theorems in statistics is the law of large numbers and the central limit theorem. The law of large numbers says as the sample size increases, the average converges to the expected value, right? The randomness is gone. The error is gone. There is no room for error at all, and it's exactly converging to the mean, the expectation. And central limit theorem says x bar is normally distributed as long as the sample size is large enough, which is quite mild. So having a large sample size is mild and easy to verify. So it's easy, and under this mild assumption, you have normal distribution, which is really nice. And when I say large, usually 30 or 35 is the cutoff, but of course, the more the better. The more the distribution will be more accurate. The normal approximation is going to be more accurate. So we considered an example, and today we are going to consider another example using the law of large number and the central limit theorem. So this has an interesting implication from this. So suppose that you have to pay $500 a year for car insurance. you pay your insurance premium is $500, say, and simply suppose that there is a randomness in car accident. So if you had a car accident, then you can claim $3,000 to the insurance company. So it may not be realistic, but let's keep it simple. So when there is a car accident, you can claim $3,000 to the insurance company, and its probability is 10%. So now let's think from the perspective of the insurance company. So insurance company collects $500 a year from you. It collects $500, and with 90%, the company does not pay you anything. Just collect $500. That's it. So its profit is $500 in that case. However, if there is an car accident, the company has to pay you $3,000, which is much more than what you paid. So the profit would be minus $2,500, which is a loss. So it's minus profit. So then, I think it's very risky. So especially with 10% small probability, the insurance company bears a huge loss, right? So you cannot manage the business like this. A company cannot accept this big risk. So then, how can they manage it? But so now, the secret is selling more insurance policies. And suppose that the insurance company sold 100 insurance policies, and also assume that each of the insurance policy holder has the same probability distribution as yours, like 10%, $3,000, and 90% nothing. And suppose that the probability of car accident is independent. So the car accident is independent across the insurance holders. So and then we are going to define X as before as the profit. So X subscript I is the profit from the ith policy holder, right? So you have 100 customers, and you may get profit from some of them, but you may incur loss from the others. So then now we are going to study the overall probability of loss. So this is X bar is the average profit. If the average profit from 100 customers is negative, smaller than 0, that means this company is incurring a loss, right? Making a loss by selling 100 insurance policies. And now we would like to calculate this probability. By the way, can you imagine we can do it? Because the information we have is really, really simple. This is it. So what I told you is the 90% profit of $500 and 10% a loss of $2,500. From these numbers, we can calculate this probability. So this shows how powerful the central limit theorem is. With very limited information, still you can calculate a lot of things. So first thing you have to do is to calculate the mean and the variance of a single outcome of the underlying distribution. So for each policy holders, the probability distribution is like this: $500, 90%, and minus $2,500 with 10%. And it's simple enough, but I want you to remind, try this again. It's been a while since you have practiced such a problem. So from this table, calculate the mean and the variance of this variable. And I'm going to continue in the next video and try this by yourself before watching the next video. Thank you.